This is Design Safe Radio, where natural hazards researchers strive to make our society more resilient to everything nature throws at us.
Hello and welcome to another episode of Design Safe Radio. I'm your host, Dan Zahner. Really happy to see you and hope you're having a wonderful day. I'm here with Alia Amer, who's a postdoctoral researcher at the NHERI Lehigh facility out in Lehigh University in the beautiful Lehigh Valley, Pennsylvania. Alia, nice to meet you today.
Nice to meet you too. Thanks for having me.
Yeah, it's great to meet you. Great to have you. Looking forward to hearing about your research. But can you tell us in a short snippet, kind of who you are, where you're from, and what your research focus is?
Okay, so my name is Alia. I'm a postdoc at the NHERI Lehigh facility, and I'm originally from Egypt, Cairo, Egypt, and I came to Lehigh in 2016, where I did my master's and PhD. Never left, still in there, which says a lot about the facility, how cool
It's
it
a really
is.
great place to be in, a great community.
Yeah, and I was involved in the NHERI Tollwood project, where we did testing at Lehigh, and we were investigating resilience of mass timber structures. Um, and now I'm broadening my area of expertise and other stuff, cool stuff.
Yeah.
So we can talk more about it later.
Great. Yeah. One of the things I was really excited about when Marty introduced us is that, your research highlights the importance of NHERI as a network. It's not just these facilities on their own, but the sum is greater than the whole is greater than the sum of its parts.
Yeah.
Right. So we have this Tallwood project that is involved, the Lehigh facility, the UCSD Shake Table, people from 20 different organizations and companies and universities. It's just been really cool to see the network come together around some of these really large scale projects.
Exactly. And all the work I'm doing right now as a postdoc, we're coming actually from dinner at workshops, at the NHERI workshops, where we start talking together, and then we came up with ideas, we write proposals, and now we're doing it. So we have collaboration with the different academic institutions that are going to use the facility, the NHERI facility, and we're helping them conduct their research. So just like the importance of networking. So came up with just a dinner, like a casual talk and a dinner, ended up with the research that we're doing right now. So
there's so many things that come out of those, in the hallway conversations or at dinner. Like we just got back, a lot of us in the NHERI network were at the American Geophysical Union fall meeting in San Francisco last week, as of this recording anyway, last week. And yeah, as you're describing, I mean, talks over coffee or or out for dinner and just talking about research, and we've come up with all sorts of ideas that are, some of them are a little wacky, but it's just those way of building community.
Yeah. So it's great. Yeah.
You have some really amazing hardware behind you in your picture there.
That's my first born child.
Hey, this large scale research at the ATLSS facility, sometimes it's hard to wrap your mind around because it's very large scale, but also a pretty complex array of equipment at Lehigh. Can you kind of describe what sort of research is enabled by things like that, those giant blue actuators there? A little bit of an overview of the capabilities of the Lehigh facility.
Okay, so we can start from the beginning. So for those who never came to Lehigh or never heard about the NHERI facility at Lehigh, it's located at the ATLSS Research Center at Lehigh University in Pennsylvania. And it's a really big lab. It's approximately 3,000 meters squared lab that has reaction walls and strong floors, and we are helping or enabling researchers and stakeholders to answer the research questions about community resilience. So we have the uniqueness to conduct large-scale experiments that can simulate the multi-directional effects of multi-hazard, and we can also include all the other interaction from other aspects like soil structure interaction, flow structure interaction. So we can have an accurate and complete simulation of the infrastructure in order to develop a resilient infrastructure. So this is the uniqueness about the lab. And we can perform dynamic or quasi-static large-scale testing. Can you see my...
Oh, there we go.
Yeah. Okay. So we can
Perfect.
these are like examples of tests that we've conducted. So you can do large-scale testing where we build like either the lateral force resisting system alone. So you can see here at the upper left, we have like the yellow frame inside the red frame. This is the specimen, which is a steel MRF test specimen, or a concrete couple shear wall, or this
What does MRF stand for? Remind me again.
moment
Is it reaction
resistant frame.
Resistance
Moment
frame.
resistant
Okay.
frame. Okay. And then, or you can build the whole sub-assembly. You can build like a part of a prototype building, and it depends on the research question. So we can perform these kind of tests multi-directional. So it can be displaced in all directions, and it depends also on the nature of the project. So we either displace the structure under dynamic testing, which is in real time, like the rate of loading is dynamic, or because the structure, for example, is very big and there's like some concerns about control, so we have to go a little bit slow. So it's going to be quasi-static.
Okay.
So this is the difference between dynamic and quasi-static. It's the loading rate of the specimen. Okay.
Gotcha. So it's not
Or
necessarily the fact that it's, a stationary or moving. It's just the
that's
rate.
the hybrid simulation.
Yeah.
So
This
that's
is what
the
we'll
cool.
get in a little bit. Yeah.
Yeah, that's the this is our like our mojo.
Yeah.
Lehigh. Yeah.
Absolutely.
Yeah.
And
So
then
we can, yeah.
to kind of describe a little bit for those who aren't watching this on YouTube, which if you aren't, you should, because she's got some great slides here. But
yeah,
when you talk about things like strong floors and reaction walls, essentially those are just very, very well constructed and braced walls and floors with a whole lot of different places to bolt things to.
yes.
So that the wall and the floor that you're bolting to won't deform or move at all when you're subjecting it to high force and high loads.
Yeah. So so this is one part, like one of the examples project. Like we can if you have a proposal and your research question requires that we have to build a whole specimen in a large scale, we can do that because we have the space and we have the capability and we have the equipment for it. Or we can conduct the real-time hybrid simulation. And do you want to talk more now about the hybrid sim? Because I have some cool videos
deeper
later.
on that later. Yeah.
Okay.
Because that'll be a whole 5-minute long thing in of itself.
Yeah. Okay.
But just describe some of these test beds that you're showing here. Yeah.
Okay. So quickly, like real-time hybrid simulation just combines a numerical model with an experimental substructure. And so for example, we can test like if you have a tall building and have dampers in different stories of the building, we can test at the same time the dampers. So we have here like a layout of 4 dampers that are used in just one building, and we can simulate the response of the structure in real time.
And you don't even have the rest of the structure built. You've just got the
it's
damper
in the computer.
itself.
Yeah.
The structures in the computer, and then you have very large actuators that simulate all of the loads from the structure and an earthquake or whatever you're trying to simulate on those dampers.
Yeah. And it's good that you mentioned very large actuators, because we have actuators that have the capacity up to like 500 kips and have a stroke of approximately like 40 inches. So we can do
That's a lot. Like for someone who's not familiar with it, like so kips is a kilo-inch pounds, right?
So if you're talking about kilonewtons, like 23,000 kilonewtons, that's a lot of force.
It's a lot.
Yeah. And we have a lot. So if someone is interested to see, like we have an inventory on our website to check if And we have also small actuators, so it depends on the
Right.
nature of the project. So for example, like here, like at the lower left figure, like we use like smaller actuator because the capacity, we didn't need like the 500 pounds. So
Yeah.
a KIPS, sorry, actuator. So it
Yeah.
depends on the nature of the project. We will assign the right actuator for your
Right.
testing. And if you can see that, so this test, for example, where we're using like a force limiting connection that is it's a novel like device for that is used in frame spine system. And
Mm.
the blue shade that you can see, that we're using DIC, so digital image correlation, in
Oh,
order to
wow.
understand more about the strains and the deformation in the connection. So we don't only rely on conventional sensors in our lab. We always expand like our expertise, so we can provide more investigation for researchers so they can understand more what's
I think
happening.
that's a really important part of what the Lehigh facility brings to the table, is that, you know, a lot of what our field researchers and reconnaissance teams are wanting to do is digital image correlation with real damage on real structures, but you need to have those models and those algorithms for that trained with good data, which is what comes
Yes.
from things like you're talking about
Yes.
at the Lehigh facility.
Yeah.
Thanks for listening to today's episode of Design Safe Radio. Be sure to like and subscribe on whatever platform you happen to be listening to this on. It really helps people find our show. Thanks to our amazing sponsors, the National Science Foundation and the NHERI Network Coordination Office, which is award number 2129782. Big thank you to Marty LaChance, our guest booker and topic researcher extraordinaire, and Raquel Ruiz, who is our video and audio editor. I'm your host and NHERI Facility Scheduling and Operations Coordinator, Dan Zahner. We'll see you in the next episode. Until then, stay resilient.